Good evening. Can you hear me? Can you hear me? Okay. Okay. First, let's move into our refresh paper, and within 1 hour, let's try to complete this very short paper, refresh number 2. You all got tute, right? Rehlan? Kabir, okay. Fatima, okay. Rehlan, are you good? No. Why? Others good. Others, Tanya, okay. Joel? Good. Others, Kabir, okay. You mean to? Uh, if not, please check post office. I think post office delay due to your area. Okay, tomorrow you can check your post office, then you can find tute back. Okay, however, we're going to start our second paper. Oh, sorry, this is not the paper, right? This is not the paper. This is 25 students. Yes, this is the paper. Okay. Is it clear? This is a paper, right? Rehlan, how I give you this paper? Are you try this paper? Fatima, are you complete this? It's a very simple question, only maths questions. Yeah, it only 10 questions, no? Okay, let me share the soft copy for others. Daily refresh. Okay, download this paper, Rehlan. Okay. Okay, come to question number 1. The line graph shows the route taken by the student from him home A to school B. The distance from the home to school along the string line. Along the string line. This is a string line. This is a school to home. The distance asking. Okay. How to get this distance? How to get this distance? Okay, this line, this dash line, the distance of this dash line asks. Okay, I got. Try to get this. I can give you 1 minute. A to B, the distance between A to B. Try to get. Kabir, I got this. It's a very simple question. Like a rational question. Okay, what's the method we can use? What's the method we can use? Dihini? I got. What is a theorem? It is Pythagoras theorem, right? Okay, this AB line, I want to get this AB line. AB line. Okay, now you want to find a method. Now it is a very complex. If you think normal, it is very complex. Yes, Pythagoras theorem is a theorem. Okay, if I complete this line as a triangle like this, see that one as a triangle. What is this distance up to this point to this point? 2 kilometers. 2 kilometers, and this total length 2 kilometer. This part 1 kilometer. Then what is the total length? It is 3 kilometer, right? It is 3 kilometer. 3 kilometer. Okay, opposite side same. This part 2 kilometer. 2 kilometer and 3 kilometer is the total. 2 plus 3, it is 5. But this 1 kilometer common, then subtract 1 kilometer, then 4. 4 kilometer is this height. Sorry, 4 kilometer. 4 kilometer. Now Pythagoras theorem, it is a right angle triangle. Now it is right angle triangle. Right angle triangle, think AB squared equal 3 squared plus 4 squared. 3 squared plus 4 squared, no need to calculate, no? 9 plus 16, then AB equal 25 square root, it is AB equal 5 kilometer. 5 kilometer, answer number 2. Who got this answer? Raise hand. Before my calculate. Joel, I got. Very simple, right? Good. They are all your questions. Dihini, I got. Great. Okay, question number 2. It is area volume of first lesson. I want to first our basic mathematics part. I hope to discuss and complete, and after that we can go to our statistic and coordinate geometry complex lessons. Okay. Find the angle of theta in the square shown in the figure. The angle of theta angle. This theta angle is asked. Theta. This is a square shape. Square shape. Okay. This square, I think if it is a square, all sides are equal, length, width, and height, all A or whatever particular value, it is same. If it is square. Now, first of all, think. Now, if you got this base square, this is a diagonal. Diagonal of the base square is this line. This is a diagonal of the base square. Diagonal means this cross line. No? Think it is x. It is x. Then x we can say now it is right angle triangle. Think it is practically right angle triangle. It is right angle triangle. X squared equal Pythagoras theorem. X squared equal a squared plus a squared. A squared plus a squared. X squared equal 2a squared. X squared equal 2a squared. Okay, then this line, I think it is y. This line, I think y. Y. Then y equal, understand, y equal, now it is right angle triangle. No? This line, and this one, this is A. If not, please send me message. Now, y equal a squared plus y squared equal a squared plus x equal 2a, then 2a squared. 2a squared. Okay, sorry, method x equal 2a now. 2a, then 2a squared. 2a squared. Now y squared equal a squared plus 2a squared, 3a squared. Y squared equal 3a squared. Okay, now 3a squared, both square root, then y equal 3a. X equal 2a, y equal 3a. Y equal 3a. Okay, now it is always tan angle is asking questions. Now actually this y value you don't need. Tan mean adjacent, opposite of adjacent, then opposite of adjacent, then tan equal tan theta equal, sorry, tan theta equal, where I can do this. Okay, I write here tan theta equal A over x mean 2a, A over 2a, A over 2a. Then theta equal tan inverse, tan get into this side, tan inverse, A to A cancel out, half. Then answer equal tan inverse half is the answer. If I calculate this part, that don't need for this question, only required opposite over adjacent, then it is tan inverse half. Understood? If you want, you can get this one also, but for answer that is not required. Are you clear? Fatima, clear? Tan inverse, don't think. Tan inverse means this is a tan inverse. Tan inverse means the tan theta equal 1 over 2. 1 over 2 means A over 2A. Then A to A cancel out. A to A cancel out. Then it is 1 tan inverse. Sorry, tan theta equal 1 over 2. Tan theta equal 1 over 2. 1 over 2. Then theta equal the question asks what is the value of theta. Then to get the theta, tan get into this side. To get tan into this side, both sides you need to divide by tan. This is a simple thing, okay? Both sides divide by tan. Sorry, tan. Then tan to tan, this side cancel out, then it is theta. Theta equal, this side tan, we can say half over tan, we can say tan minus 1. Tan minus 1 half. Understood, Dini? Okay, next question, very simple. Question number 3. Rehlan, I got. Abir. Question number 3, only 3 answers given, right? 2 answers missing. Okay, let's try. A tree on the street fell down 6 meters from the base as shown in the picture due to storm. What is the height of the tree? What is the total height of the tree? What's the total height of the tree? Actually, total height of the tree means 6 meter plus. The total height of the tree means 6 meter plus this length, right? This length. Okay, now we can get this, think it is x equal Pythagoras theorem, x squared equals 6 squared plus 8 squared. No need to calculate 6 squared plus 36 plus 64, it is 100. Then x equal 10. X equal 10. X equal 10 meter. Then total height of the tree is 10 plus 6, 16. But answer missing. Yeah, fourth answer write down as 16. Answer 60. 60. The x length 10, the total height maybe base part then it is 16 meters. Okay, question number 4. Pillars marked A, B, C, D are fixed in position on a horizontal plane as shown in the figure. Height of D. How we get this height of D? Okay, this is a D. This is a D. Okay, what to do? Okay, let me draw this one in our board. Okay, this is the given figure. This one 6 meter. This is A, B, C, D. 6 meter, 9 meter. The distance 3 meter. AB distance 3 meter. And BC distance 10 meter. 10 meter. And CD distance 20 meter. C to D distance 20 meter. Okay. I got this. The height of D asking the question. Okay, I can give you 1 minute for calculate. Okay, sorry, there was connection issue. Okay, are you done? Can you hear me, right? You can hear me, right? Abir? Yes. Where we discuss this one. Okay, are you done? What's the D height? What's the height of D? What's the D height? Good. Others, Fatima, Rehlan, what's the height of D? You had enough of time to do this question. Okay, the height of D. Okay, they are. It is given. It is 2017 exam question. 2017 exam question. Okay, first of all, I can draw dash line like this. See. Okay, then now you can do this question. This length 3, they are vertical lines, therefore this length also 3 meter. 3 meter. Okay, up to this level it is 6, right? Up to this it is 6. Now you can say these all angles, you already know these all angles are same. These all angles are same because same slope. Same slope. It is same straight line. Remember that if you draw, this is the same straight line. If you draw any parallel line, any number of parallel line, these all angles are same. All angles are same because same slope. Same slope. Okay. Now, same slope. Now, this one up to this level, it is 6 meters. Up to this level, this part 6 meter because of this same level. Now we can say theta equal, if not, we can complete this. No? This is a right angle triangle. Theta equal, yeah, this theta also same. Yeah, this part don't need. Without that one also we can find this. Okay, now this angle theta, this part 3 meter and up to this level it is 3. This part also 3 meter, right? 3 meter because 3 plus 6 it is 9. It is given. Then this part 3 meter, this horizontal length also 3 meter. Now we can use tan theta. Tan theta equal opposite of adjacent 3 over 3. What is this? Tan theta equal 3 over 3, it is 1. Then tan theta equal 1. Tan theta equal 1. Tan theta equal 1 mean what is the value of theta? Theta equal tan inverse theta. So tan inverse 1. Actually, if you got this value, tan inverse 1 mean tan inverse 1 mean theta equal 45 degrees. Okay, that don't need make on but tan theta equal 1, right? Tan theta value 1, however, tan theta value 1 because tan theta equal opposite of adjacent. It is opposite 3, adjacent 3, 3 over 3, it is 1. Tan theta equal 3. So tan theta equal 1. Tan theta equal 1 mean this all theta, it is same. Now you can see this length 10 meter. Now 10 meter mean this part also 10 meter, because tan theta equal opposite, think opposite x over 10. Then tan theta equal 1 equal x over 10. X equal 10. X equal 10. This part 20. Then this part also 20. Because tan theta equal 1. How we got this? According to this given data. According to this given data, I found tan theta equal 1. Then tan theta equal 1 means this length and this length is equal. Okay, now it is up to this level, height up to this level 9. 9 plus 10, 19. 19 plus 20, 39 meters. The total height of the, okay, up to this level 9 meter. 9 meter, and this is 10. 9 plus 10, it is 19 plus 20, it is the total height of D equal 39 meters. Answer number 4. Anyone got this answer before me? Raise hand. Yeah, they are the exam type questions. Not exam type, exact exam questions, past paper questions. Who correct? Kabir correct. Others? Okay. Could you please explain again? Okay. This is the method, sir. Okay, let me draw and explain again. Clearly understand. This is the given figure. This is the D. This is the A, B, C, and D. The question asks, what is the height of D? What is the height of D? The total height up to this level, 6 meter. Total height of this one, 9 meter. 9 meter. Total height of this one, don't know. Total height of D, don't know. Okay. Then if I draw a dash line, dash line gahagattama, then this length, this is 3 meter, it is 10 meter. What are the lengths? And 20 meters. They are given. AB equal 3 meter, BC equal 10 meter, and CD equal 20 meters. Now, Sarmya, can you understand up to this level? Up to this level, it is 6 meter. This part 6 meter means the total height 9. Then this part is 3 meter, right? And this horizontal one also 3 meter. If you got this theta equal tan theta equal 3 over 3, it is tan theta equal 1. Tan theta equal 1. Clear? Tan theta equal 1. Tan theta equal 1 mean, now you can understand up to this level it is 9. Up to this level it is 9. This is up to this level it is 9. And this one 10 meter, then this part is then how we get think this is x. Okay, make x කියලා හිතන්න up to this level. Then tan theta equal, if you got tan theta for this triangle, tan theta equal x over 10. X over 10. Then tan theta equal 1 according to this one, x over 10. Then cross multiplication, x equal 10. X equal 10. Then this x height is 10. Then C total height is 19. The total height of x is 19. Okay, now the same thing up to this level. What is the height? 19. 19 meter is up to this level. Okay, then if you got this part, you can get the total height of D. How we get this small height? Then it is theta. Then again tan theta. Opposite y, think this part y over adjacent 20. Then tan theta equal 1. Y over 20. Cross multiplication, y equal 20. Then 19 plus 20, it is 39. Clear? The D total height equal 39 meters. Sir, may I clear? Dihini? The total height of D equal 39 meters. Okay, try these questions again. Try these same questions again. A small cone of 20 centimeter height has been cut and removed from the large cone of 40 centimeter height as shown in the picture. Predict the volume of the remaining part. Good question. Predict the volume of the remaining part. Okay. Okay, let's draw. I got the answer. Yeah, they are very good practice questions. Okay. Not the problem is it is not clear the radius. No? A small cone of 20 centimeter height has been cut from removed from the large cone 40 centimeter height shown in the picture. Predict the volume of the remaining part. Okay, what is a radius? Let's open our soft copy. Is it clear? Yeah, it is 30 centimeter. Yeah, the diameter, right? Yes, the diameter equal 30 centimeter. Diameter equal 30 centimeter. Diameter equal 30 centimeter, and this part cut out. The total height equal 40 centimeter. The total height 40 centimeter. This total height 40 centimeter. Small part 20 centimeter part cut out. 20 centimeter part cut out. Okay, the remaining part volume, that means this base part volume. The base part volume is asked. Okay, what is the method? First of all, you need to calculate the total cone volume of the total cone, and subtract the small part. Okay, how we get this small total cone? How we get the area of volume of the total cone? Total cone volume. V equal 1 over 3 phi r squared h. 1 over 3 phi r squared mean the diameter 30, as I think, but I am not sure. Okay, let's try. Think diameter equal 30, then radius 15. 15 into 15, height 40. Okay, then it is cancelled out into 5. Okay, what's the value? 5 into 15, it is 75. 75 into 4, 300, 3005 cubic centimeter. The total cone volume is 3005. 3005. Amina, I got the tube pack. Amina. Yes, good. Okay, we are doing the second paper. 3005. Am I correct? Yes, 14. Okay. 3005. Then small cone, you can get the small cone area. Sorry, volume. Small cone volume. Okay, what is the radius of this part? What is the radius of a small cone? The total height 40. The cut out small cone height is 20. Then what is the small cone radius? Remember, small cone radius, this one 15, then this one 7.5 centimeter, not meters. Sorry, centimeters. How it is coming? It is height divided into 2. The height ratio, the total 40, 20 centimeter height part will be removed. Then the removed part area, so radius also divided into 2 from the full cone. Then it is a small cone 1/3 pi r squared h 1/3 phi r mean 7.5 into 7.5 height 20. Okay, get this value and send me. 7.5 into 7.5 into 20 over 3. $375 5, right? 375 5. Then remain part, remain volume 3005 minus 375 5. 3000 minus 375, what's the value? 2625 5. Answers given in without 5, then multiply with 5. 8,246. Okay, 2,625 multiply with 22/7, then you can get the correct value, I think. Okay, what's the value? 2,625 multiply with 22 divide by 7. Yeah, 8,250. Correctly coming answer. Answer number 2. Understood? Very simple question. I got the full cone volume. Then I got the small cone volume. I subtracted. This is removing means volume decreasing. Then the remain part, the base part volume, 8,250. 8,250. This radius I got according to the ratio, the height full height 40 centimeter and small cone height 20 centimeter. 20 centimeter cut out from the full 40 centimeter cone. Then the remaining part volume, sorry, removing part volume radius is 7.5 because the total radius is 30. So the total radius is 15. The total diameter is 30, then removing part diameter is 50. Understood? They are always asking questions. Joel, clear? Tanya, clear? Answer number 2. Please try this question. If you, Fatima, are you correct this one? If you're doing mistake here, please try again and practice the same question. They are exam type questions now we are doing. Exam MCQ type questions. Okay. Okay, first, now we got 1 hour. Okay, let's quickly complete this one and let's move into our biomolecule lesson because today I need to do our part of model paper for 25 students also. Therefore, I need to finish this one at 9:45 only today. Okay, the problem, we don't have fixed time now, no? Okay, what's the most suitable time for our revision? What do you think? I hope, are you all okay Wednesday morning? Then Wednesday morning we can do revision and Wednesday evening we can do, continue with our theory class. No? Are you okay all? How about this time then? Every day? Every day this time? This time mean only today we complete 9:45. We have to continue up to 11 p.m. 6 to 11, 5 hours. Okay, let's see that. Okay, question number, it is 8,250. Okay, a car traveled at a speed of 45 meters per second on a circular road with the radius of 0.5 kilometer. 0.5 radius means it is 500 meters, right? 500 meters. What is the angle of the radian? This angle in radian it is asking. Which the car turned 10 seconds. Turns 10 seconds. The car rotate 10 seconds. Okay, now first of all, we can find the arc length, no? The car travel distance. Car travel distance. Arc length equal, the car speed is 45 meters per second. 45 meters per second mean within 1 second, how many meters? 45 meters. Then the car travels 10 seconds. 10 seconds mean 450 meters. 450 meters. Then arc length equal 450 meters. Arc length means the car travels distance. Car travels distance. Okay, now the angle in theta, the equation we already discussed in the rotational motion, theta radian equal S over R, arc length over radius, that we discussed in our rotational motion lesson. Okay, then arc length equal 450, the radius equal 500, 0 to 0 cancel, both divide by 5, then it is 9, it is 10. then theta radian equal 9/10 radian. 9/10 radian, answer number 4. 9/10 radian, answer number 4. Okay, let's quickly complete this. Okay, don't miss this biomolecule. Today we're going to discuss all the structures of carbohydrate. It will be very important. We discuss linear and circular all structures and aldose, ketose, every structures. It will be very important for your other future chemistry lessons. Don't miss this. A metal plate used by a designer for design is shown in the figure below. What is the area of the shaded part AOB? AOB and COD circles of orbital is O. Phi equal 3.14. Phi equal 3.14. Okay, what is the method? Okay, if I draw, okay, the diameter of the large circle, now this is a large circle, its diameter is given, it is 12, then this radius is 6 centimeter. The large semicircle radius is 6 centimeter. But now this is 3 centimeter, right? This is 3 centimeter. 3 centimeter means this arc length, this is small arc length, this part to this part. C to D arc length equal 3 centimeter. And this angle given 0.4 radian. 0.4 radian mean how about this angle in degrees? What's the value in degrees? Amina. 0.4 radian. 0.4 radian mean okay, actually don't need. Okay, note down these equations. They are the most important equation. If you got any arc length, so if sector part, this type, sector part with this theta radius and theta degree and r radius, they are very important for your exam, these equations. The theta radian, theta whatever theta angle and radius. Okay, first of all, the S mean arc length. S mean this curve arc length. Okay, if you want to get this arc length, if you use theta in degrees, this is the equation. Theta over 360 2 phi r. 2 phi r mean circumference equation. Theta multiply with theta over 360. Think this angle is 60, then you can use 60 over 360 into 2 phi r. If you use arc length, if you use to find arc length using theta in radian, then this is the equation. S equal r theta radian. S equal r theta radian. This is how you got this equation. Theta radian equal previous equation. Theta radian equal S over r. Then S equal r theta cross multiplication. Okay, this is the two equation to get the arc length of any sector. If you use angle in degrees, this is the equation. If you use angle in radian, this is the equation as S equal r theta. Okay, if you're going to calculate the area of this type sector, area equal, if you use angle in degrees, this is the equation, theta over 360 pi r square. Theta over 360 pi r square. If you're going to find area of this type sector part, if you're going to use angle in radian, this is the equation half r squared theta radian. Half r squared theta radian. Please keep remember and note down, prepare a short note of these four equations. Okay, they are the frequently used equations for essay and MCQ math questions. MCQ math questions. Okay, note down quickly. Okay, now you can use this one. Okay, now this is 0.4 radian. Then I can use the arc length is given. Arc length is given. The phi also given. Phi also given. Okay, now I can use S equal R theta. Okay, what is the S? The arc length given 3 centimeter. No? Arc length equal 3 centimeter. Radius, let's this one equals 0.4 radian. 0.4 radian. Now the radius equal 3 over 0.4. What's the value? It is 30 over 4. 30 over 4 means 7.5. 7.5 centimeter. The radius equals 7.5. That means the total O to OC length 7.5. Total OC length equals 7.5. 7.5. This one 7.5. 7.5 centimeter. Now you already know this part. This part is given. This part is given 12. Then this one 6 centimeter. 6 centimeter. 6 centimeter. This radius, because half the diameter is given. Diameter given, then it is 6 centimeter. The large radius is 7.5 centimeter. Okay, now you can find this angle. Okay, first of all, you can find what is the meaning of 0.5 radian value. Okay, how 0.5, 0.4 radian, how convert into degrees? What's the method? 0.4 degrees, sorry, radian, how convert into degrees? What's the method? 0.4 multiplied by 180 over 5. I think you can remember. Degree, so radian convert into degrees. Degrees convert into radian multiply with 5 over 180. Radian convert into degrees 180 over 5. 180 over 5. Then 0.4 into 180 over 5. 5 value is given. 5 value equal 3.14. 3.14. Okay, then can you send me quickly what is this radian degree value? Kabir? Abhi, what is this degree value? 18 into 4, it is 72. 72 over 3.14. Okay, if not, මෙහෙමත් ගන්න පුළුවන්. The theta in degrees equal 72 over 5 degrees. Any method? All okay. 72 over 5. Now let's take 72 over 5, then 5 to 5 cancel out. Okay, now 72 over 5. 72 over 5. 72 over 5. It means what's the value? 2293. 22.93. Okay, now you already know the full, this is 22.93. 22.93, this degree. Okay, now you already know the full angle of this type semicircle, it is 180 degrees. 180 degrees, then what is this angle? $180 degrees. $180 minus 22.93. It is 157.07. Take approximate value is asking. Approximate value, then 157. 157. The area equal 157 over 360 5 into 6 into 6. Oh, it is don't have answer. Yeah, it don't have answer. This answer 49.1. Centimeter square. It's a mistake. Okay, no problem. Okay, this one, 8. A student is expected to remove part A from the metal pyramid. Part A from a metal pyramid shown in the figure, and the construct a ball from the remaining part B. The volume of the remaining part B, the base part area is asked. The base part volume, volume is asked. Okay, how to get this height? 6 centimeter. This is 7 centimeter height. Okay, the same method, get the full full pyramid area, then subtract small pyramid, not volume. Full pyramid volume, subtract small pyramid volume. Okay, what is a full pyramid volume? 1/3 base area, 10 into 9, 10 into 9. Full pyramid, 7 plus 6, it is 13. 3. Full pyramid volume, 13 into 30. 390. Small pyramid volume. 1/3 base area, 4 into 3, multiply with 6. Then 3 to 3 cancel out. 24 cubic centimeter. Then the remaining part, 390 minus 24, 366. Answer number 2. Answer number 2. Answer number 2. Okay. Question number 9. Question number 9. The diagram shows a circle with center O and radius 4 centimeter. The diagram shows a circle with center O and radius 4 centimeter. Yes, this radius 4 centimeter. RS is an arc of a large circle and center O. The angle POQ is 0.45. POQ 0.45. Radian 0.45 rad. 0.45 rad. If P and Q are the midpoint of OS and OR, then PQ are midpoint mean this part also 4 centimeter. This part also 4 centimeter, right? OS and OR respectively. What is the area of the shaded region PQRS in terms of phi? The shaded region is asking. The shaded region area is asking. Okay, how to get this? How to get this? The shaded area, this shaded area is asking PQRS. PQRS shaded area is asking. Okay. I got this. I got this. Dihini. Okay, what is the method? First of all, you can get the OSRO sector full area. Then subtract this small area. What is a full sector radius? 8 centimeter. Small sector radius 4 centimeter. Then all data given. Okay, the area of sector. Now sector area, I told the equations. What is the equation? The angle given 0.45 radian is the angle. Then you can use half r square theta radian. They are the equations. They are the equations. This is the equation you can use. This one. Area equal half r square theta radian minus, I'm going to get directly the answer, the shaded part, r1 squared half r squared, r2 squared theta radian. Okay, now half r1 squared mean the full one, full sector, it is 8 into 8, theta equals 0.4 minus half r small radius, that means small part radius 4 into 4, theta means 0.45, that one also 5. Okay, now what to do? 2 to 8 cancel out, it is 4. 4 into 8, it is 32. 32 into 0.4, what is the value? 32 into 0.4. 32 into 0.4. 12.8. 12.8 minus 2 and 4 cancel 2. Then 2 into 4, 8. 8 into 0.4. Sorry, it is 5 minus 2 into 4, 8. 8 into 0.4. 3.2. 3.25. 12.8 minus 3.2 is the answer. I think it is 9.6. Answer number 2. Okay, are you clear all? Yeah, before that, I think this question I have done mistake, whatever. Okay, let's try this question again. Okay, let's try question number 7 again. I got answer. I hope I did mistake. Okay, let's try this question again. මම එක තැනක මිස් කරා මම හිතන්න. Okay, the total length 12 centimeter. And 3 centimeter 0.4 radian. 0.4 radian. Okay, let's try this question again. Okay, are you clear up to now? Without this question, other all questions okay? Then message. Dihini? Tanya? Joel? Okay, yeah, this question, let's try. I think I have missed one step. Okay, let's try. I don't know. Is this answers given or not? Okay, let's try again. Okay. Now what's the time? Okay, 8 now. Okay, no problem. Do you need interval after before we start the biomolecules? Okay, let's see. The total diameter is 12. Total diameter means this total length. A to D total length 12. This is the O. This is a B. This is a C. This is a D. Yeah. This is a shaded area. The question asks, what is the value of shaded area? What is the value of shaded area? Okay, first of all, I can find this radius. Then S equal R theta. S equal 3 centimeter. R we don't know. Theta 0.4 radian. Now R equal 3 over 0.4. It is R equal 7.5 centimeters. 7.5 centimeters. Okay, then this radius 7.5 centimeter. This is the point I have missed. Okay, this radius 7.5 centimeter. That one also, the total is 7.5 centimeter. Okay, now total is given. Okay, that's a mistake. Okay, 7.5, the total 12. Then the remaining part is the small sector radius. The remaining part 12 minus 7.5, what is the value? The small sector radius 12 minus 7.5. 12 minus 7.5. It is 12 minus 7, it is 5. 7.5, it is 4.5. Am I correct, Habib? This part 4.5. Then how about this length? If you want, you can get this length 4.5 and 7.5, the gap 3 centimeter. Gap 3 centimeter. Then yes, correct. Now correct. Okay, now the shaded area is asking. Shaded area. How to get this? First of all, we can get this angle that I found 157 degrees. 157 degrees. Now, what is the equation? The area equal theta over 360 pi r squared. Theta over 360 means 157 over 360. Pi value is given 3.14. R squared 4.5 into 4.5. Okay, can you get this value? 27.7. 7 square centimeter. Area. Okay, is this any answer? Yeah. Answer number 4, right? Yes, answer number 4. Previously, I have done mistake. Sorry, correct that. Previously, I have done mistake. I have found, see, I have found it is 7.5, but mistakenly I have got it is 6. Yeah, that's how I have done mistake here. Okay, this is wrong. It is, if it is 7.5, this length equals 7.5, very simple. My mistake, okay? 7.5 centimeter, and then total 12, it is 4.5. Remain part is 4.5. Kabir, correct? It's my mistake. Methana 6 නෙමෙයි එකයි වැරද්ද. Others are correct. It is 4.5. If you add 4.5, then you correct. My mistake. Okay. 4.5. 4.5. Fatima, clear? Okay. Okay. Practice these questions again and get familiar, because this type 10 questions coming in exam paper, 10 MCQ questions and 1 question from area and volume in essay part. Therefore, 7.5 for essay question and 17.5 very important part. Therefore, practice and getting familiar this equation and calculation methods. Okay. Okay. Do we need break, or we can start the biomolecules? Do you need break? I can give you 10-minute break, or we can we continue up to 9:45? You have only 1.5 hours. Okay, let's start now. It's still 8. Okay, we can. Okay, let's move into our get your biomolecule tube. You all have tube now. Only 2 students don't have. They can check tomorrow morning. Please check in your post office. Okay. What we discussed up to now in biomolecule lesson, I told last day, the biomolecule. What are the biomolecules? Biomolecules mean biomolecules. Okay, what are the biomolecules? Actually, biomolecules mean molecules important to biological structures. Biological structures like carbohydrate, proteins, lipids, nucleic acids, they are the biological compounds. This compound produced by a molecule. These molecules we called as biochemicals. Sorry, biomolecules. This compound produced molecule, always compound produced by molecules. This compound produced molecule we called as biological molecules, biomolecules. Okay, last day I told in worldwide 92 different types of molecules have found in our periodic table. up to now 92 elements. It is not all. Up to now, the found amount is 92 elements, 92 molecules. Among those 92 molecules, 30 molecules important to produce biological structures. In our body, 30 molecules contain. Among these 30, four molecules, very important for the biological structures. What are they? What are them? Carbon, hydrogen, oxygen, nitrogen are the very important biomolecules for production of our biological structures. Carbon, hydrogen, oxygen, and nitrogen. They are the main biological. Biological molecules important to produce biological structures. Okay, last day I explained. If you got hydrogen, I'm not going to explain about again about nucleus, proton and a neutron, contain proton and neutron. Then it is positive charge. The energy levels contain electrons. Due to this positive charge, they have attraction to the nucleus. Then this is hydrogen. This hydrogen nucleus, and this is first energy level. Then this is an electron. Hydrogen only one electron, one energy level. Okay, if you got oxygen, how many outer electrons? How many electrons in outer orbitals? 1, 2. Outer orbitals. 1, 2, 3, 4, 5, 6. No. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Oxygen means 8 electrons. 8 electrons mean first energy level. First orbital, it is 2 electrons. And outer orbital, second orbital, 6 electrons. 6 electrons mean 3 couples. For stable stage, they need 4 couples, 8 electrons. But oxygen have only 6 electrons in outer orbital. Orbital means energy level. Okay. Nitrogen. How many electrons? Total. How many electrons in second orbital? Kabir? Nitrogen. How many electrons in second orbital? Send me. Others, how many electrons in nitrogen outer orbital? Tanya? Outer orbital, how many electrons? Outer orbital. Nitrogen. Fatima? Dehini? Yes, 5. Yes, 5. 5 electrons mean 1, 2, 3, 4, and one single electron. Then for stable, they require 3 more electrons. For hydrogen, they required 1 more electron, then hydrogen can stable. Oxygen need 2 more electrons for stable state. Nitrogen, 3 electrons required for stable. Carbon, very important. Carbon, first orbital 1, 2, second orbital only 4. 1, 2, 3, 4. Carbon, very important. They need 4 electrons for their stable stage. For their stable stage, they need 4 additional electrons. 4 additional electrons. Therefore, we called for always inside the biological structures, these biomolecules not like to retain as molecules. Molecules mean unstable stage. They don't like to have in unstable stage. Therefore, they always try to what? Become stable. They always try to become stable. Due to this requirement, this hydrogen, oxygen, nitrogen, carbon, they combine and production of different compound. They we called as biological compounds in our biological structures. What's the story? This hydrogen, oxygen, nitrogen, carbon, they don't like to have an unstable state. Therefore, they always try to become stable stage. For stabilization, what they doing, they combine different other molecule, and they share their molecules with other electrons. Then what they doing, they they producing different compounds for their stabilization. Okay, that's the story. Okay, are you clear up to now? Very important. Very important. Are you clear up to now? Udanya? They are unstable. First, you need to understand they are unstable. Why they are unstable? In the final orbital, they don't have full. If it is stable, they need 8 electrons in final orbital. For hydrogen, they need 2 electrons. Okay, what they doing? They produce different compounds. They are molecules. Molecules produce different compounds for keep their stability. Clear, Kabir? Okay. Okay. Now, okay, this is the story given here. Okay, draw hydrogen structure, oxygen structure, nitrogen structure, carbon structure in the given boxes. Hydrogen, oxygen, nitrogen, carbon in the given boxes. Okay, finish. Complete. Complete. Okay. Okay. Among them, carbon is considered as the main building block of the life. That is very important common features of carbon. Carbon is the, I told, from 30 elements, molecule, 4 molecules very important. Among them, the uh, carbon is considered as the main building blocks. The carbon is the most important um, biomolecules important to produce biological structures. The carbon we can find everywhere carbon. That's the meaning. Okay, without carbon, actually in our we are not available actually in the life. All our structures, not only us, plants and all microorganism also, the main compound is carbon. The main biological molecule, carbon. Okay, this question always asking, special characteristic of carbon. Why this carbon is everywhere in living structures? Why this carbon everywhere? The first one, the ability of carbon atoms to bond with many other carbon atoms through carbon-carbon bond from large complex chain. Okay, this one I explained last day. Diamond, graphite like, they can produce large complex structures like this. Okay, last day I explained carbon is very special because before that, for stable, hydrogen can produce 1 bond, oxygen can produce 2 bonds, nitrogen can produce 3 bonds. 3 bonds mean forget stable, they can produce 3 bonds with other molecules. Carbon very important, they can produce 4 bonds, maximum 4 bonds. That's why we call carbon is very important. They can produce maximum number of bonds with other elements, other molecules. Therefore, carbon can make as a very complex structures like this. Carbon, very complex structures. This is outer energy level, outer orbital electrons. Okay, outer orbital electrons of carbon. Then they can produce more strong covalent bond. Covalent bond means they can keep electrons commonly, like they can use these electrons commonly. Then by this strong covalent bond, carbon to carbon, strong covalent bond, then they can make as very large complex like this. This is a complex, carbon to carbon, it is a complex. That's the main characteristic. That's why very important. This carbon can organize as very strong and complex, very strong and large complex chains. Okay. The other thing is they can ability to produce strong covalent bonds. Strong covalent bonds. You need to remember them. The carbon has special ability to produce special more strong covalent bond. The next one, it is very small and very small molar mass and small atom with small molar mass and commonly available in the earth. It is commonly available. That's why it is important for produce biological structures. The other thing, ability to form multiple bonds between carbon. Multiple bonds mean the carbon can produce single bonds like this. Single bonds, they are single bonds. If not, carbon can produce double bond. Carbon can produce triple bond like this. Carbon to carbon triple bond. Carbon to carbon triple bond. And double single bond like this, double bond and triple bond, all bond types they can produce between carbon chain. That's why this carbon element, carbon molecule is very important for biological structures, produce biological structures. What are the factors? They can produce as very complex structures. That's the first thing. What's the second one? They can produce strong covalent bond. Third one, they are available everywhere in the earth and their mass and molar mass very small level. Atomic mass and molar mass very small level. And they can produce carbon to carbon single bond, double bond, triple bond, all bond types, and they can produce as very large complex structures. I got the points? I got points? Dihini? You need to remember them. Any doubt? Any doubt up to now? Okay. Okay, today this week the problem is now still 25 students still not complete the SFT. Therefore, this this week very busy with 25 students. After 25 students exam complete when 21st SFT second paper. SFT second paper 21st mean what's the date? Next Friday. And this week very difficult. After next Friday we can do our works normal, but these days are very busy. Okay, I have given carbon special characteristics that you can find about carbon, and everywhere in carbon, carbon monocubes everywhere, in dress, in cotton, in different foods, everywhere carbon is the main source. Okay, as I told earlier, always biomolecules, they not like to have in unstable stage in our body. They always try to become stable stage, stabilize. Okay, for stabilize, what they doing? This unstable biomolecule, they combine with different molecules and convert into compounds. Compounds. These compounds, these compounds, mainly two types. Mainly two types. What are the compounds? Compounds are inorganic compounds and organic compounds. Inorganic compounds and organic compounds. Compounds, understand the story. These molecules always like to have in stable stage. For stabilization, what they're doing, they combine with different other molecules and convert into compound. These compounds, mainly two type, organic compounds and inorganic compounds. Organic compounds and inorganic compound. Organic compounds and inorganic compounds. Okay, what is the meaning of these organic compounds? Fatima, what are the meaning of this organic compound? What is the meaning of this inorganic compound? What's the difference? Khabir, Dihini? What's the meaning of this organic compound and what's the meaning of this inorganic compound? Yes, good. Normally, in simply, we can say carbon available compounds, organic, carbon not available compounds, carbon absent compounds, inorganic. Don't contain carbon called as inorganic compound. Okay, in simple level or O level, it is correct. But if you got carbon dioxide, carbon dioxide organic or inorganic? If you got carbon dioxide, is it organic or inorganic? Now it is stable. It has carbon and two oxygen. Is it organic or inorganic? What do you think? Amina? CO2, carbon dioxide, organic or inorganic? Good. Carbon dioxide is an inorganic compound. Why? It contains no carbon, Fatima. Why carbon dioxide is inorganic? It contains carbon. What is the reason? Always remember, organic compound we can't Actually, we don't have exact definition for organic compounds. Organic compounds mean carbon available and carbon hydrogen bond available. That means hydrogen තියෙන්න carbon and carbon hydrogen bond available. Carbon available, carbon hydrogen bond available compounds. Carbon available, carbon hydrogen bond available compound we called as organic compounds. Then inorganic compound mean carbon hydrogen bond not available mean carbon කොහොමත් නැහැ. Carbon hydrogen bond not available. Bond not available compound. Not available compound. Okay, go to the note. It is given inorganic compound. Compound which don't contain carbon make a change කරගමු. Carbon and carbon hydrogen bonds. Carbon and both they must have carbon and carbon hydrogen bonds are known as inorganic compound. Yes, carbon dioxide, carbon monoxide. Carbon dioxide means CO2. Carbon monoxide means CO. Carbon not means CO3. Water means H2O. Water, however, water don't have carbon. Sulfur dioxide, SO2. They all are inorganic compound. Understood? Raise hand. Understood? Wait. Okay, what's the story? It is actually these lessons are like a story. Okay. Beautiful story. Okay, I told this are කලින් කියපු previously I told molecules. Molecules not like to have in unstable state. As molecule they don't like to have in our body in living structures. Then what they doing? They combine with different other molecules and organize as a compound. These compounds now they are mainly two types. What are the two types? What are the two types? Organic and inorganic. Organic mean carbon and carbon hydrogen bond available. Contain carbon and hydrogen bonds. Inorganic mean they don't have carbon. They don't have carbon and carbon hydrogen bond. Actually, mainly carbon hydrogen bond not available compounds we called as without contain carbon hydrogen bonds we called as inorganic compounds. Inorganic compounds. H2O, they don't have carbon. No? They don't have carbon mean carbon hydrogen bond not available. Okay, but organic compound mean which contain carbon and carbon hydrogen bond. Both. දෙකම තියෙනන් තමා එකක් තිබ්බට මදි carbon තිබ්බට මදි they must have carbon hydrogen bonds. Compounds which contain carbon and carbon hydrogen bond are known as organic compounds. Those organic compounds that build up living body. Okay, they are the examples for carbohydrate, proteins, lipids, nucleic acid. They are the example for organic compounds. Carbohydrate main compound molecules are carbon, hydrogen, oxygen. Then you can see carbon, hydrogen bond. Protein, carbon, hydrogen, oxygen, nitrogen, carbon, hydrogen bonds. Lipid, carbon, hydrogen, oxygen, phosphorus. You can see carbon, hydrogen bonds. Nucleic acid, carbon, hydrogen, nitrogen, phosphorus, carbon, hydrogen bonds available. I got the point, Tanya? Compounds with carbon, hydrogen bonds called as organic compounds. compounds without carbon hydrogen bonds we called as inorganic compounds. Very simple. Okay, again, carbon compounds without carbon hydrogen bonds called as inorganic compounds. Compounds with carbon hydrogen bonds we called as organic compound. Fatima, clear? Okay, very simple story. Okay. Okay, as I explained, the biomolecule definition is given here. Biomolecule produced in living cells is called as biomolecule. Yes, molecules produced in living cells called as biomolecule. These are chemical compound that must exist in all organisms. Yes. Yes. Okay. Now let's move into our first organic compound. Other thing, in this lesson, we mainly going to discuss about organic compounds. We're not going to discuss further about inorganic compounds. Only organic compounds we discuss. Then the first organic compound is carbohydrate. The first organic compound is the carbohydrate. Okay. Okay. I hope you already know about carbohydrate in O-level time, right? Carbohydrate. Okay, before that, please, I hope you all have TUT. Now only 1 or 2 students, they can get TUT tomorrow morning. Tomorrow morning. Now, Danya, you don't have TUT, right? I couldn't post yet. Second batch, second group. Okay, then what to do? Okay, you can ask my soft copy, then I will say. Okay, carbohydrate. Our first organic compound is carbohydrate. Okay, what are the carbohydrates? What are the carbohydrates available foods? Carbohydrates available foods. Examples? Carbohydrates available foods. Bread, rice, yes. What else? Mainly carbohydrate sources, foods. Potatoes, right? Potatoes, sweet potatoes. What else? මේස් mean මේස් කියන්නේ මොනවද මේ බඩ ඉරිඟු. What else? Barley, yes, barley. Okay, they are carbohydrate available foods. Okay, actually now we're going to discuss the overall story of the carbohydrate. Try to understand the full story, then you don't need to again memorize and I පාඩම් කරන්න ඕනේ නැහැ. Okay, try to understand full story of the carbohydrate. Okay, The carbohydrate is the most abundant, that means most available organic compound in the earth. The cellulose. Cellulose is a commonly the most available carbohydrate types in the earth, because the all plant cell wall is made with cellulose. The cellulose is a carbohydrate type. The cellulose is a polysaccharide type. Okay. Other than starch, now you told all food sources, the main carbohydrate type is starch. Then everywhere in grains and seeds, the main food source is starch. They are produced during the photosynthesis of green plants. Yes, in the photosynthesis, the main product is carbohydrate, glucose. Then they convert into starch and stored. Potato, sweet potato, grain, sugar, sugar also carbohydrate. Do you know this? Do you know sugar? What is the sugar carbohydrate type? Starch, no? Potato, sweet potato, grains, they are starch. Sugar mean what is a carbohydrate type? Normal sugar? Sucrose, very good. Sugar means sucrose. Sucrose is a disaccharide, starch is a polysaccharide. Okay. It's wheat flour are some of the example for foods which contain carbohydrates. Okay, mainly in in photosynthesis process, what is the main product? What's the main product? The main product is glucose. You already know, in the carbohydrate photosynthesis process, using carbon dioxide and water, it is produced glucose. This is a photosynthesis equation. CO2 plus H2O. If you don't know, please note down. CO2 plus H2O plus O2. Then 6 for balance the equation. Okay, now it is the balance equation of photosynthesis. Carbon dioxide and water produce glucose and oxygen gas. Oxygen gas released to the atmosphere. Now you can see the glucose is the main product of photosynthesis. All green plants, the main product, glucose. The glucose is the carbohydrate. Then this produced glucose convert into sucrose and starch and stored in the plant parts. Understood? Then you can, everywhere the main food source of the earth, carbohydrate, right? The main food source. Plants produce carbohydrates. Okay. Second point, identification of characteristic of carbohydrate. Identification of carbohydrates. This if anyone given structure, whatever structure, you can find is it carbohydrate or not using these characteristics. The main characteristics, the main element composition of carbohydrate, carbon, hydrogen, oxygen only. It is very, very important. The main characteristic of carbohydrate, many characteristics. Carbohydrate. Carbohydrate, if any structure is carbohydrate, it has three main characteristics. Its composition, carbon, hydrogen, oxygen only. It's only available carbon, hydrogen, oxygen. No nitrogen, no sulfur, no phosphorus, no any other molecule. It is carbon, hydrogen, oxygen only, remember. Carbohydrate composition එකේ තියෙන්නේ carbon, hydrogen, oxygen only, no any other molecule. Remember, that is the first characteristic. The second one, carbohydrate at least they contain at least 3 carbon atoms. It is very important. At least 3 carbon atoms are තියෙන්න ඕන. Then think this one. This one. Is it carbohydrate? Is it carbohydrate? Yes or no? Dihini, is it carbohydrate? C2H6O5. Is it carbohydrate? No. What is the reason? It has only 2 carbon atoms. If carbohydrate, what is the main requirements? This is basic, okay? Basic, they should have at least 3 carbon atoms. If not, they're not carbohydrate. Glucose structure C high H dollar high O6. This is a glucose. More than 3, always. More than 3. More than 3. The final characteristics, hydrogen and oxygen ratio. Hydrogen oxygen ratio always 2 to 1. See, hydrogen 12, oxygen 6. Hydrogen oxygen ratio always 2 to 1. Okay, they are the main characteristics of carbohydrates. What are the characteristics against? They are in the composition, they only contain carbon, hydrogen, oxygen only. They only contain carbon, hydrogen, oxygen. The second one, number of carbon atoms more than 3. The third one, hydrogen and oxygen ratio 2 to 1. That means hydrogen 2 na, oxygen 4. Sorry. Hydrogen 2 na, oxygen 1. Hydrogen 4, oxygen 2. Hydrogen. See glucose structure. Two to 1. I got the point. Okay, the final one, the common molecular formula CxH2OY. See, CxH2OY. As example, think it is 6, like this. This is a glucose formula. Okay, now what is the actual mean? H6 into 2, it is 12. Always oxygen, this value. I got the point. Always hydrogen oxygen ratio 2 to 1 according to this formula. I got the point. Think another example. Think another example. C3. This is a common equation. This is a common equation. Cx H2OY. Make it up with them C3 H2O4. See, then that's the meaning C3H8O4. According to this formula, always hydrogen oxygen ratio, what happened? 2 to 1. It is, sorry, it's 4. Hydrogen oxygen ratio 2 to 1. Are you good or not? Clear? Okay, I got up to now. Salmia. Salmia, I got. Okay, then revise again. What are the main factors? What are the main characteristic of carbohydrate? What are the main characteristics? Okay, let's write again. The main characteristic, the number of carbon at least 3. 3 number of carbon at least. The second one, the composition only carbon, hydrogen, oxygen only. Carbon, hydrogen, oxygen only. The third one, hydrogen oxygen ratio always 2 to 1. The common equation X CX H2O Y. Remember? I remember. Fatima. Do you remember? Okay, compulsory to remember. Okay. Again, revise. Only carbon, hydrogen, oxygen composition. Hydrogen oxygen ratio 2 to 1. At least 3 carbon. And the common formula CX H2O Y. CX H2O Y. Okay, now carbohydrates, according to their formation, carbohydrate mainly 3 types. Carbohydrates, according to their formation, they mainly 3 types. 3 main types that you already know in O-level time, right? The first one, monosaccharide. The second one, disaccharide. Final one, polysaccharide. Monosaccharide, disaccharide, and polysaccharide. Monosaccharide, disaccharide, and polysaccharide. Monosaccharide, disaccharide, and polysaccharide. Okay, don't think about this example. We can discuss example one by one later. We can discuss examples later. Don't think about this example, those given example. Okay. And don't think about these formulas. These formulas we can discuss one by one in our discussions. Okay. Now, the first carbohydrate group or the building block of carbohydrate is the monosaccharide. Monosaccharide is the building block of carbohydrate. Carbohydrates, the building block or the structural unit. The structural unit or the building block we called as the carbohydrates. Carbohydrates. They are the simplest structures, building blocks. They are commonly known as the simple sugars. Yes, all monosaccharides are simple sugars. I will explain what's the meaning of these simple sugars. They are characteristic. They are water soluble. We can discuss later. Okay. According to the number of carbon, monosaccharide, we can classify it into 5 categories. I told monosaccharide or whatever carbohydrate, how many number of carbon at least? How many number of carbon at least in carbohydrate? How many number of carbon at least? 3, right? If any carbohydrate type, disaccharide, polysaccharide, it is more than 3. Always it is more than 3. Monosaccharide, if any compound to be a monosaccharide, the number of minimum carbon should have 3 carbon atoms. Remember, the number of minimum carbon atoms must be 3. Okay, the number of minimum carbon must 3. Okay, according to the number of carbon, very important, according to the number of carbon, we can classify it monosaccharide as given in the table. Think any monosaccharide contain only 3 carbon atom. The common name we called as, the group of monosaccharide with 3 carbon atom, they called as triose. TRIOSE, triose. Triose. What are the examples? Glyceraldehyde. Note down, glyceraldehyde. Dihydroxyacetate. Acetate. Okay, they are the examples for trioses. They are the examples. Trioses mean monosaccharide with 3 carbon atoms. Monosaccharide with 3 carbon atoms. Monosaccharide with 3 carbon atoms called as triose. That means very simple structure, right? At least 3 carbon. Okay, monosaccharide with 4 carbon atoms we called as tetrose. Tetrose, examples note down. Erythrose is a erythrose. Need to remember, okay? Compulsory to remember. Erythrose is an example for this tetrose. Tetrose means the carbon number 4. Monosaccharide with 4 carbon atoms. Tetrose, erythrose is example. Pentose means 5 carbon number 5. 5 carbons. Remember examples: ribose, ribulose, deoxy, ribose. Ribose, ribulose, deoxyribose, all are pentose. Ribose, ribulose, deoxyribose. This ribose important for produce RNA. Deoxyribose important for produce DNA. Okay. Okay, the final one, if any monosaccharide contains 6 carbon atoms, that we called as hexose. Hexose. Note down examples: glucose, galactose, fructose. Fructose or fructose කියලා කියමු. Fructose. Glucose, galactose, fructose. Glucose, galactose, fructose. Glucose, galactose, fructose are the examples for hexoses. These hexoses are the most available monosaccharide type in the earth. Remember, therefore, in this lesson, we're going to discuss further about deep understanding about these hexoses. Okay, the final one, heptose, the number of carbon 7. The number of carbon 7, they we called as heptose. Write down example: heptulose. Heptulose. It is heptulose is a monosaccharide with 7 carbon atoms. Then it is heptose. Okay, revise again. Carbon 3. What is the name? Triose. Triose. Glyceraldehyde, dihydroxyacetone. Dihydroxyacetone. Acetate. Dihydroxyacetate. Triose. Tetrose. Erythrose. Erythrose is example. Pentose. Ribose, ribulose, deoxyribose. Hexose, glucose, galactose, fructose, heptose, heptulose. Trimine, see, actually this name's not too advanced. Trimine 3. Trimine 3, right? The carbon number 3. Tetramine 4. Penmine 5. Hexmine, hexagon 6. Hepmine 7. Clear? How we classified them? According to the number of carbon. According to the number of carbon. Amina, do you remember them? Okay, complete. Complete. Complete writing. Okay. Then again tell carbon 3 triose, glyceraldehyde, dihydroxyacetate. Carbon 4 tetrose, erythrose. Carbon 5 pentose, ribose tubulose deoxyribose. Carbon 6 hexose, glucose galactose fructose. Carbon 7 heptose, heptulose. You must remember them. Okay, now previously we classified carbohydrate according to the number of carbon. According to the number of carbon. Now we're going to classify monosaccharide according to the functional group. According to the functional group of monosaccharide. According to functional group, monosaccharide, again we can classify it into two main categories. Don't take very complex. First, carbon Gana, according to the number of carbons, we can classify it. They are groups. Now, in second way, according to their functional group, their structure functional group, again we can classify this monosaccharide into two categories. The first one is aldose. The second one is ketose. Aldose and ketose. Simple. If any carbohydrate or monosaccharide, aldehyde group present contain aldehyde group. Aldehyde group mean, remember, this is the aldehyde group mean this type. Group එකක් කොහේ හරි තියෙනවා නම් their structure, that is aldehyde group. That's an aldehyde group. It is given here carbon, hydrogen, oxygen. This actual shape, okay? Carbon, double bond, oxygen and hydrogen. Anywhere in the structure, if this structure contain aldehyde group, remember aldehyde means C. You must remember them. Today, after today class, you must revise them again. These names and concept stories very well. Otherwise, you can't do this question. You can't do this lesson. Okay, not only this lesson, after that, all chemistry lessons, this is a method you have to go through and revise again and again and again, same thing, and remember everything. Okay. This is aldehyde group. If any monosaccharide present aldehyde group, that we called as aldose. It is classified into aldose, aldehyde functional group. If any monosaccharide present aldehyde functional group means COO with hydrogen. This monosaccharide we called as aldose group. Clear? The second one, if any carbohydrate, if any monosaccharide present, ketone group. Ketone group means C. This is a ketone group. If any monosaccharide present ketone group, the difference is methane connecting carbon, connect hydrogen. That's the difference. If any monosaccharide present ketone group, that we called as ketone group. So the ketose. Ketone is a functional group. If any monosaccharide present ketone functional group, that we called as ketose. Harnit, understood? Okay, note down these terms. This is a aldehyde group. This is a ketone group. Up to now, clear? Are you clear up to now? Quickly. We have only 10 minutes. We need complete up to 2 pages. All structures we need to complete today. Okay, quickly send message. Are you clear up to now? Hari. May balana next part. Okay, now I am going to discuss. I told among this, according to number of carbon, according to the number of carbon, according to the number of carbon, I told the main carbohydrate group in the earth is hexose. Okay, now hexose example, glucose, galactose, fructose. I'm going to explain. I'm going to explain their structures. Now, further about glucose, galactose, fructose, very, very important things, compulsory exam questions. Okay, before that, aldose group examples එකක් ලියලා තියන්න මෙතන. Please note down example for aldose, glucose and galactose. Glucose example, glucose and galactose. Glucose and galactose, aldose monosaccharides. Aldose monosaccharide. But fructose is a ketose. Fructose is a ketose. Okay, come to lesson. Okay, now I am going to draw glucose linear structure. Try to understand. මෙන්න මේ කොනෙන් අදින්න. හරිද? මේ left side එකෙන් අදින්න. Draw it in left side. Keep space for right side for the 3D structure. 3D structure. Okay, this is the glucose linear structure. Okay, first of all, glucose is hexose or triose or pentose or what? How many carbons in glucose? How many number of carbons? Joel? How many carbons in glucose? Good, it is 6. Therefore, it is hexose. It is hexose. Now, write down linear structure. Linear structure. Carbon, 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 carbon. How many carbon? 6. 6 carbon. 6 carbon. Second step, carbon numbers 1, 2, 3, 4, 5, 6. Carbon 6. 6 number of carbons. 6 number of carbons. Okay, don't draw. Adinnepa palan. Okay, how many number of carbons? 6. Oh, now you can hear. Okay, what we discussed, the glucose is a hexose. Therefore, number of carbons 6. 6 number of carbons. 6 number of carbons. 6 number of carbons. And they are the number of carbons. This is a glucose structure. Now the second step, I numbered this carbon number up to 6. 1 to 6. Okay, third step, glucose is aldose or ketose. Is glucose is aldose or ketose? Glucose aldose or ketose? Fatima? Glucose aldose or ketose? Dihini? Niti නෑ නේද? Now 9:22. Tanya? Glucose aldose or ketose? Yes, it is aldose. The glucose is aldose. Good. If it is aldose, what is the aldehyde group? It must have aldehyde group. Okay, aldehyde group the end on. Okay, this is the aldehyde group first. I told CO hydrogen is the aldehyde group. This is the aldehyde group. Carbon aldehyde group. C ketone group. Ketone group. Now it is aldose, aldehyde group. Aldehyde group. Okay. Remember, this is OH. 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 In glucose structure, except third carbon, all linear structures, remember, third carbon is difference. Very simple. The first carbon going to aldose structure, aldose, then second carbon, fourth carbon, fifth carbon, sixth carbon, equal side. Right side is OH. Right side OH. All structures, third one is different. Third one is hydrogen. Now what is the next step? All carbon should have 4 bonds. Now first carbon, 1, 2, 3, 4. First carbon 4 bonds completed. Now second carbon, they must, this is opposite one, you need to, මෙතන opposite එක තමයි දාන්න ඕනේ, opposite එක. OH hydrogen, hydrogen OH. OH hydrogen. OH hydrogen. OH hydrogen. Now you can see the final carbon is still not completed. Therefore, we can add another hydrogen. Okay, this is the structure of the linear structure of glucose. This is a linear structure of glucose. Are you clear? If you know this, then make structure you can't draw this. You must know the pattern. Why we add 6 carbon? Why we add aldehyde group? Why we add OH except third carbon? Third carbon, every linear structures, third carbon is opposite. Third carbon, hydrogen OH opposite. That's why we change this. Other all same. Clear? Fatima? Others, are you clear? Amina? Kabir? Okay, now this same structure, we can draw this way. Carbon, 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 6 carbon, aldose 1, 2, 3, 4, 5, 6, aldose group, aldehyde group, OH, 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 hydrogen, hydrogen, OH, hydrogen, hydrogen. This one, can you see the final carbon? CH2OH. අපි මෙහෙම ලියන්නේ නැහැ සාමාන්‍යයෙන්, that we can say CH2OH. That's a final structure. Okay, that is a final structure. You have to draw this again. Okay, draw, and this is a final structure. CH2OH we can draw in this way. Okay, let me share your syllabus, how it is given in your syllabus. Okay, now today we have to stop here, but don't miss next week class, because if you go tuned, we have a lot of structures, more than මේ වගේ structures ගොඩක් තියෙනවා. Not only monosaccharide, disaccharide also a lot of structures. Then if you missed any part this lesson, again you can't understand. Until exam you can't understand. Okay, this is a final chance. Don't miss next week class. Okay, let me share how they given in syllabus. මේක කොහොමද දීලා තියෙන්නේ කියලා. Okay, this is your syllabus. Syllabus means teacher's guide. Okay, this is the glucose structure. The problem, it is only in Sinhala. This is the glucose structure. Okay, let me explain next week how it is remove this carbon. They have removed this carbon. මේ මෙතන මේ වගේ carbons තමයි තියෙන්නේ. Then you should know. After discuss all structures, I will explain how to draw in this way. See, only third carbon is the different one. Other all are same. This is aldose group. Aldose group. CH2OH is the final one. Clear? These junctions are carbon. Okay, don't think about them. Okay, next week we need to discuss this circular 3D structures, alpha glucose, beta glucose, then galactose, everything, and then disaccharide, this fructose, and sucrose. Okay, not easy, but not too difficult or too easy. If you covered well, you can draw these all structures. See, all the structures you can draw after you complete this carbohydrate part. Therefore, don't miss from tomorrow we can get 5 hours, but the problem is now 9:30, 9:45. I need to start 25 students paper discussion. Okay, then let's meet next week with all structures and refresh paper 3. Please make sure to complete refresh paper 3 before yeah, question numbers, final 2 questions you can't discuss. You can't still do these final 2 questions. Yeah, you can, after complete this biomolecule, you can try this refresh paper biomolecule questions. Okay, any doubt from today class? From next week mean 21. Okay, let me share what is our final revision day. I hope we can get morning time, right? Okay, morning time or evening time easy. You all are private, not going school, right? Morning time or evening time easy. Send me. Morning easy, no? Okay, then let's do it in morning. I think Tuesday morning or Wednesday morning. I will share details in the group. What is our final day? Again, we're not going to change. The problem is 25 students. 25 students next week safety will be completed. Then we can continue our revision as normal, as usual. Okay, practice one more time. This is structure. That's not only, we have a lot of structure. See, only space here. We need to draw. Therefore, don't miss next week class. Next week, kinetic chemistry and biomolecules, both important. Next week classes. Don't miss any class. Yeah, that's all. Let's meet next. I will let you know what is the final date. That we can take morning time. Okay, goodbye. And students who don't have got tudes, please check your post office. Okay, goodbye.